Hello everyone, so we are back with Leetcode daily challenge. In today's problem we need to construct a string from a binary tree. So a tree is given, like a binary tree is given, and we need to like add parenthesis to the pre-order traversal of that tree, right? And we need to also remove the unwanted parenthesis in the pre-order traversal. For example, in this example given below, what we need to do, 1 is there, it is the root, then 2 is there, so a parenthesis will be started at 2, like it will open, then we move to 4, it will open a new parenthesis for 4, then 4 data will be there, then the parenthesis will be closed for the 4. When we return back to 2, the parenthesis will be closed and we return back to 1, then we again go to the third 3, parenthesis will open and the data of 3 will be added, and then the parenthesis will be closed. So this is the like desired result. So the result should be like 1 2 4 and 3, but at first what the result should be look like, when we also consider the null part, then we can have some null parenthesis like for all the null part, right? So these parentheses are not required, like here in the example you can see, like after 4 empty parenthesis is there, it is the right part of the 2, and similarly after 3 2 empty parentheses are there, it is the left and right respectively part of the 3, right? So we don't need to use the unwanted parentheses, we just need to make the string such that only the required parentheses are there in the string. But this is very much confusing question, because in the next example they are using a empty parenthesis, right? When you see this example, first example, you might have an idea like we don't have to add a empty parenthesis, like if there is a null, then we don't have to add a parenthesis. So this can be a simple solution, but it is a bit confusing because in the second part they are using a empty parenthesis. So it is not clear in the question like why they are using, but what I figure out that if there is a right part of a node, like for example for this node, if there is a right part and there is not a left part, right? So in that case we need to add a empty parenthesis. So the main logic is here that if a node have right part and if it does not have a left part, then only we have to add a empty parenthesis, else we have to follow this logic only. So first of all I will write the code for the pre-order. I hope all of you know about the recursive approach of pre-order. So if we take a void function as pre-order, which will take a root as argument, then what pre-order does, it takes the root element, then it goes to the left of it and then right. So we will do some operations here for the root part, then we will call the function for the pre-order root dot left part, and then we will again call the function for recursive function for pre-order root dot right. So this is the like basic skeleton of the pre-order function using recursion. Now first we have to check like if root is null, then we will return, right? So this is a basic skeleton of a pre-order function. Now what we need to do, like if we follow the question, we need to add parenthesis, right? So what we will do, like for the first root part, what we will do, we will have a check like if root dot left exists, then what we will do, we will add the answer. Like in the root part, what we will do, we will convert the like this number form, like the number in the node, into a string form, right? So how can we convert? We will take a global answer variable, it will be our string, right? And we will add the like we will use the toString function plus equals to to underscore string in C++, and we will take the like integer part like root dot val. So this function will convert the root dot value to our string in the form of string, and it will add it to the answer. So this is the first calculation for the root part. Now when we move to the left of the tree, what we will do, we will first check whether left of the tree exists or not. Then what we will do, we will push like answer plus equals to empty, like we will add a opening bracket opening parenthesis, and in the second case what we will do after completing the left part, what we will do, we will add like closing braces, right. So this is for the left part, but for the right part what we need to do, we need to check, right, what we need to check, like whether the left part exists or not, because if the left part exists, as in this example below, we need to add an empty parenthesis. Sorry, my bad, if the left part does not exist, then we need to add a empty parenthesis. So in the right condition, like for the right condition, we will check if root dot left equals to null, right. What we will do, we will answer plus equals to like empty braces, right. And similarly for the next next line, what we will do, we will simply answer plus equals to open braces, open a brace, and when the right part is finished, we will close that brace, answer plus equals to close that brace. So this is a very much simple solution, but what we need to keep in mind that if root when we check the condition for the right part, we also need to check the condition whether root dot left exists or not. If it does not exist and root dot right exist, then in case we have to add a empty braces. So this is the main tricky part of this question. It is a confusing because it is not given in the question, like we need to consider the left part when there is a right part. So I hope the pseudocode is clear. I have written down all the code. We just need to use this pre-order function in our main function. We need to return the answer. I am not writing the code in the Leetcode because I don't have my keyboard with me. I am traveling. So I hope it is clear. Thank you for watching.